Hello, my name is Jan Kilbay, and this is my video report for the first task of the Cloud Computing Capstone project. This project consisted of analyzing a transportation dataset provided by the US Bureau of Transportation Statistics. So the first part of this video is explaining and walking through how I cleaned and stored the data. So after looking at the data description on the BTS website, I started by uploading the relevant files into S3 from which I would start further processing. To clean this data, I created two Lambda functions. The first Lambda function is used to clean one single file. It would read this file directly from S3, decompress it into memory, then extract only the relevant files, and finally then upload back the information or the new data files into S3. The second file, the second Lambda function would scan my S3 bucket for the files that I just uploaded and trigger an execution of the first Lambda function for each of those files. So the next part of the video is walking through the results of the different questions in the different groups. So I used the Hive on an EMR cluster in combination with DynamoDB for the questions in group 2. So if we now look at the questions for group 1, yes, I have here a Hive CLI. I already applied some of the optimizations that I found that helped in improving the performance. So if we now take the first query and we execute this query, this will take a few seconds to complete. So I will continue executing this. I will also already execute the second question from this group, and I will come back once this processing is done. As we can see in the output, Hive has created a number of map and reduce workers and executed them and then returned results. So these are the results for the first query or the first question in group 1. And these are the questions or the results for the second question. Then now if we move on to group 2, group 2 require to store the results in either Cassandra or DynamoDB. So I chose to store this information or the results. So I chose to store the results in a DynamoDB table. I will start by, well, for each of the different questions I created a separate DynamoDB table. I will start by creating the DynamoDB table. Voila, DynamoDB table is created. Then next I create an external table into Hive that maps onto the DynamoDB table, does the mapping of the Hive fields onto attributes in DynamoDB for each of the different items. So here I have another CLI already. Create the table. The external table is now ready. And then I have my queries that will extract all or create all the results to the different questions and insert this into a into the DynamoDB table. And then with a second query, I extract the requested results for each of the different questions. I will continue to create a DynamoDB table and map corresponding Hive table and do all the processing for the remaining questions of group 2, and then I will return back with the results. So we can see that meanwhile the computation for the second group of questions is done. So these are the results of the first question of the second group. And these are the results for the third group. In the third question in the second group. And finally, for the last question in the second group. Next, we move on to group number 3. So the first question there is, does the popularity distribution of airports follow a zip distribution? To answer that question, I created a query that would make a rank frequency table. And here are the results of this query. So we can see we have the airport, we have the number of incoming and outgoing flights, and the rank. Import this information into a spreadsheet and make a diagram of this. We can see on the vertical axis we have the number of flights, on the horizontal axis the rank. So here, for example, we have the airport with the most amount of flights, and here the least amount of flights. The axes are logarithmic scale, and in such a graph, a zip distribution would be a straight line going down, which is clearly not the case. So the popularity distribution is clearly not a zip distribution. So then over to the second and final question in this group. So I will first start already the query that can be to process it in the background. And meanwhile, I will give some explanation. So basically, this query consists of two subqueries. So the first subquery will select all the flights that match the requirements for the first flight. The second subquery does the same thing for the second flight. For each of the selection of flights, I apply a rank based on the least amount of delay. Then I combine the results of both sets of flights in such a way that it meets the overall requirements that, for example, the second flight has to leave 2 days after the first flight, and that we only select the flights with the least amount of delay. Then the next I store the information into a separate Hive table on which we can perform the queries to get the results that we want to see. And that's the final query. And voila, those are the results that were requested. This concludes the video report. I'm now looking forward to start with the second task.